All right, so this is 19,
Yeah.
which says that I have some plane, right? And this plane is given by 3x plus 2y plus z equals 1. And someplace over here is the origin. Right? And I'm supposed to find the closest thing on the plane to the origin. I'm going to move my origin a little bit. That was purely pictorial. Pay no attention. So I want to find the kind of corresponding point so that this distance here, right, is as small as possible. You guys cool with that? And they give you a hint. They said by minimizing the square of the distance. Because your initial instinct, right, is to minimize the distance. You guys see that? So my kind of initial instinct would be to say, okay, here's a point P, right? How far is P from 0, 0, 0? Yeah, I mean, okay, so P is maybe, let's think x, y, and z, right? And so I'd go, all right, the distance from P to 0, 0, 0 is x squared plus y squared plus z squared square root, right? So this is the function, right? D of x and y and z. That's the function I want to try to minimize, yeah?
They want the square.
Except that the partials of this are going to suck, right? So instead of measuring distance in actual distance, measure distance with a capital D. It's actually just squared distance, right? If I make the distance squared as small as possible, then the distance will be as small as possible, right? You guys all buying into that?
Yeah.
That's really because the squaring function is increasing for positive x's. Right? As the distance goes up, the distance squared goes up. So, well, this seems dumb. I know how to make x squared plus y squared plus z squared as small as possible. You put in x is 0, y is 0, and z is 0, right? But where's the other thing I'm missing? I'm missing some damn thing here.
You need a point on the plane.
Yeah, it's got to be a point on the plane, right? So how do I make it?
Wouldn't it be perpendicular to that point, whatever that optimized point is? Wouldn't it always be
You know what, Chris?
perpendicular?
That's not what I'm doing right now.
You need that information.
Yeah, you totally could, but shut up. Yeah, that's a great way to do it. Another thing you could do is you could notice that this needs to be perpendicular, right? And so you could figure out something, I don't know, that maybe 3, 2, 1, that's perpendicular to the plane, right? You guys see that? And then you could see where the vector 3, 2, 1 starting at 0, 0 hits the plane. That would be enough. You guys see that? That would give you an answer. But that's not what we're doing, so shut up, Chris. So how do I do this with the distance thing? How do I make this and that play nice? Yeah, that's a good idea, right? Take a look at this thing and think to yourself, that really means z is 1 minus 3x minus 2y, right? Take that, cram it in here. So now you're dealing with the function capital D of x and y, right? Where'd the z go?
It is the D.
Yeah, I just got rid of it, right? So I got x squared plus y squared plus
1 minus 3x.
plus all that crap squared, right? You guys all with me on that? Okay. Now what? So get yourself dx and dy, right? These should be easy. Get 2x.
Forgot the x, y.
And then plus
Thanks.
6 in parentheses, or no, minus 6 in parentheses.
Minus 6 times whatever's in the parentheses here. And 2y minus 4, whatever's in the parentheses.
Wait, we should have a, oh, never mind. I see.
Good?
Yeah.
What did I forget?
The 6, you did,
Oh.
it was just like multiple.
I let them do it, I didn't do it.
Yeah. I saw it. Step with me.
Okay, so then you multiply this chunk out, right? So you get dx is 2x
2 times 3.
plus 18x is
Yes.
20x
Huh.
plus 12y minus 6. And dy is whatever you get. Oops, forgot a parenthesis. How come you guys let me do that?
Negative 4.
So I
Because
think
I'm too
that's
busy copying this down.
10y's, 12x's, and minus 4. Okay, do some arithmetic, get to here, maybe. Get to a place that looks like here, because I probably made a mistake. Then what? Yeah, set them equal to 0, right? Okay, so you got 10x plus 6y is 3, and 6x plus 5y is 2. Yes? And then solve by elimination. So take this guy and multiply by 3. Take this guy and multiply by negative 5. So you should get 30x plus 18y is 9. And negative 30x minus 25y is negative 10. Give or take. So up to arithmetic error, I'm getting minus 7y is negative 1.
Yay, more
Why does it always have 7? Seriously, why so many 7s? Okay, so you get y is a 7, and x is then x equals number.
Yeah.
Good? You guys all know where to get x, right?
Yeah.
Trot your 7th back to one of your equations, cram it in there and solve. Okay, so you get y is a 7th and x is a number. And why do I think this is a minimum? Oh, and where the hell do I get the z?
Yeah.
Well,
You can
plug
plug it
in the
into
equation,
the
the
z equals.
original,
Into what equation?
the z
The
equals,
z.
This one?
no,
No.
the z equals 1 minus 3x.
Good, yeah. Plug it back into the equation for the plane to get the z value, right? You guys cool with that?
Give me a second to get.
So you get whatever you get. You get x is number, y is a 7, and z is different number.
3/14 for x.
Yeah, and actually, I don't even care if they're all positive here. So the signs on these numbers don't matter at all. The thing that's making this a minimum is the fact that this guy, right, this whole d function that you started with is a paraboloid, and that it points up. You guys all with me on that? It's a upward pointing elliptic paraboloid. If it was an upward pointing hyperbolic paraboloid, you would have,
So the minus one.
We couldn't do it, right?
yeah, you would have a saddle, right? And that would say that there isn't a closest point on this plane to the origin, which is a little bit trippy feeling.
Is that what happened if you do it with a sphere that was centered around the origin?
If you do it with a sphere that's centered around, like if you try to calculate the distance, the closest point on a sphere centered at the origin to the origin, you'll get everything's a critical point, and they're all maximums.
They're all massive.
It'll be really confusing. You won't be able to use this logic. Like, this thing won't be a paraboloid. It'll probably be a constant, right? In fact, it should be a constant because it should be the radius squared,
Yeah.
right? And so if this is a constant, then you take a derivative, right? You set it equal to 0. It's always 0. You take a second derivative and try to calculate that d thing, and you get garbage out of it because it's always 0 anyway, right?
that would be-
So then you have to, like, scratch your freaking head on that one a little bit. But yeah, that's a good case, right? Sometimes this breaks down. Sometimes there will be a couple points that are closest, in which case you might have some weirdness to deal with here. But on this one, it's pretty easy, right? This is a paraboloid. It's got one minimum value. It's got to be the critical point that I found. It can't be anything else. This doesn't have any other behavior going. And the geometry will tell you that, right? So another thing you could do is this thing where you do this perpendicular deal. And yet another thing you could do is this thing that you might think would be a good idea with a computer, which is where you take your plane, right? And you start here at the origin and you just make little spheres,
Oh, gosh, that could be hard.
right? And you just kind of like put a little air in them and see if it touches the plane yet. And if it doesn't, you put a little more air in it, right? Does it touch the plane yet?
And you just keep going until it touches.
Yeah, just keep going until it touches, right? And the first point at which it touches, well, that's your closest point.
You could probably optimize that by taking big steps and then go back once you hit, and then.
Yeah, or you could do Lagrange multipliers, which is the thing we're going to do. So yeah, this is an easy Lagrange multipliers problem too. Which, and don't think Lagrange multipliers is any, well, it's a little bit more advanced than puffing up a ball with air, but it's not a lot more advanced. Like, that's pretty much the idea. Cool? All right. Oh, the other thing, this thing with the perpendicular, right? That's actually just the tiniest bit hard to do. I glossed that like it was really, really easy.
It's a lot harder.
And it's not that easy, because what you have to do is you have to, like, oh, what the hell, let me do it that way quick. Or at least let me sketch that way quick. Okay, so you pull your normal vector out of your pants or wherever you get your normal vector. Your normal vector here is what? 3, 2, 1. And what's special about that normal vector?
It's perpendicular to the plane.
Yeah, it's perpendicular to the plane, right? So I know that if I go from the plane along that normal vector, right? Whichever one of those goes through 0, 0, 0 is going to be my winner, right? You guys see that? But there's like two parameters there. You guys see that? There's like moving around in the plane and making this vector kind of longer and shorter and trying to see if it hits 0, 0, 0.
So some scalar multiplied by that vector equals some unknown point on the plane.
Yeah, that's probably a little bit complicated. I'm going to go the other way. I'm going to think about that situation exactly opposite. I'm going to start from 0, 0, 0, right? Start here and run out that vector. You guys see that? And see when I hit the plane. You guys see that?
That's it.
So this thing here, the red guy, that's some constant, right? Positive or negative, I don't really know, because I don't know whether this normal vector sticks down or up. It sticks up, but who cares? If the constant's negative, right, it'll take care of that. So just take some constant, multiplied by 3, 2, 1, right? You guys see that? So what I'm really thinking about is I'm kind of thinking about a line with slope 3, 2, 1 through 0, 0, 0, right? You guys all see that? And then I want to know when that thing hits the plane, right? Okay. Make that an equals-y thing for me. What do you do? This equals, how do you put the k to the vector thing?
3K, 2K, 1K.
Yeah, good. I'm doing scalar multiplication, right? So I got a vector 3k, 2k, k. And I want to know when that hits the plane, right?
Okay.
So how do I make this category of thing that category of thing?
Could you, would you have to cross it, like pick 2 points?
Too much.
3KX, 2KY, and KZ
So close.
equals 1.
Okay? I'm down with the equals 1 part. So 3x, right? What's x?
I.
3K,
Oh,
3K, so
yes,
it's 29, okay.
The square, the
Yeah, so this is totally cheating, right? Because this thing's a vector. But really what I'm doing is I'm looking at it and I'm thinking about it as a point. And then I'm taking that point and I'm cramming it into here.
So it's
You guys see that?
Okay.
So that's a little bit funny. You should think twice about doing this. But what I'm really doing, right, is I'm going out along that vector and then I'm talking about the point that's at the end. And I'm taking that point and I'm shoving it in here.
So we have gain 114K.
So I'm getting 9k plus
4K plus K.
4k plus k is 1. So k is 1 over 14.
Wait, why are those squared? Those code, the 9, 4, and 1? Why are
Oh,
those squared?
because 3x times 3k is
okay,
9k.
yeah.
You guys all good with that? Okay, what the heck does that tell you?
We did plug that.
That's the,
Yeah,
that's a scalar.
We plug that in for
No.
K for
That's a
the.
scalar, but
Yeah, this is the scalar, right?
not the.
This is like if you're standing at the origin, right, and you point your laser,
Right.
your vector, right,
Oh, cool.
up in the air and push the button, this is kind of how long it takes to hit the plane.
Yep.
Does that tell you what point at which it hits the plane?
Not quite.
Not yet.
Almost,
You just
right?
have to multiply that to the current 3 to 1 vector.
Yeah, so you take your k and shove it in there, right? And so you get
3/14, 1/7.
3/14,
1/7.
1/7,
1/14.
and
1/14.
1/14.
And guess what that is?
And I really hope the 1/7 was the y I got a while ago, but I can't remember, and don't tell me if it's not. No, it was, right? It better be.
It is.
So this is my closest point on the plane, and what did I get for this approach? I had to think a little bit harder, right? But I had to do
So much less math.
so much less arithmetic anyway. You guys see that?
Yep.
I would argue that this was more mathy and less arithmetic-y, because I had to like think a little bit harder about my shapes.
Yeah.
Guys cool? Questions, skills? This actually bears a lot more resemblance to Lagrange multipliers than the other thing did. Really?
I noticed that the answer to this is the normal divided by the square of the distance. So is that kind of like a shortcut almost? It asks us to find something that's closest to the origin by minimizing the square of the distance?
Yeah, basically that happened because we were going through the origin, right?
So that won't work every time.
No, in general that's a little bit more complicated. But yeah, that's a nice observation, right? Because I was going through the origin, my line was just this, there was no plus whatever. And that intercept, that plus whatever, is going to screw up that thought. But you can shift everything so it works. It's just that your normal vector will end up shifted around a little bit. That thing that I just said is actually really hard to do in practice. What was your question, Mark? Do you have one?
Oh, I was
No?
going to talk about like line defined in terms of vectors.
Yeah, we're not there yet. So I haven't told you guys, right, that this was really fair. Because I really said, well, we're going to think about this like a line, right? But I haven't given you any real, like, this is really like a vector function, right? You guys see that? Like, really, if you think about what this thing does, this is taking k's, right, like real numbers, and turning them into vectors in R3 or points in R3, right? So this is like a function that takes R1 and puts it into R3. I haven't told you guys that's fair yet at all. You guys can envision this thing happening. Because you do this all the time, right? You throw a ball through space, right? And that ball is a function, right? The position of that ball in space is a function of time, but it has three outputs, right? You guys all see that? There's like an x position, a y position, and a z position. All of those are tied to that of t thing, but we don't know how to do anything with those yet. So this was a little unfair. Cool.